let's start paper 1, multiple choice, base level chemistry, February, March 2024, variance 12. Duration of this paper is 1 hour 15 minutes. We have 40 questions in this paper and we need to attempt all of them. The total mark for this paper is obviously 40, which means one question has 1 mark. Also, do not write in the barcode. You can use the calculator. Let's see what we have in this paper. Which species contain the same number of neutrons? So I'm looking for the same number of neutron as carbon 14-6 and the same number of electrons as this. Okay, now first of all, let me give you the composition of carbon 614. It has an atomic number of 6, which means it has 6 protons. So it has 6 electrons. 14 minus 6 becomes 8 neutron. All right. So I'm looking for the 8 neutron. And let's talk about the sodium ion here. Sodium ion has a charge of +1. It has a proton number of 11 and the mass number 23. So it has 11 proton. It has 10 electrons. And then 23 minus 11 becomes 23 minus 11. 23 minus 11. Hold on a second. Minus 11. 12 neutrons. Okay. So I'm looking for 10 electrons. So species contain 10 electrons and 8 neutrons would be the right answer for me. All right. So one by one, let's talk about fluorine first. We have 9 protons. We have 9 electrons. And we have 17 minus 9 is basically 8 neutron. So obviously, we have 8 neutron in this. If you can check, we have 8 neutrons, right? But we don't have 10 electrons, which means A is absolutely incorrect. Let's talk about option B. We have 7 proton. We have 10 electrons. And we have 16 minus 7. It's going to be 9 neutron. All right. So we have same number of electrons, but not neutrons. Obviously, B is also incorrect. Let's talk about neon. We have 10 protons, 10 electrons, and 10 neutrons. So we have same number of electrons, but not neutrons, which is why option C is also incorrect. So if A, B, C are incorrect options, obviously D is going to be the right one. But let's talk about the D. Let me give you the composition here. We have 8 protons. We have 10 electrons because of 2 minus charge. 2 electrons will absorb, and so the total electrons would be 10. And 16 minus 8 is going to be 8 neutron. Now, guys, check. We have 8 neutrons and we have 10 electrons. So this particle has same number of electrons and neutrons as carbon and sodium plus ion, which means D is going to be the right answer. Okay. So that's question number 1. I believe that was the easiest question. Which process is the largest enthalpy change per mole? Since each equation has the loss of electron, which means this enthalpy change is going to be the ionization, all right? Because of the loss of electron, enthalpy change is going to be ionization enthalpy or ionization energy is the same thing. Now, aluminum, phosphorus, silicon, and sulfur. So, first of all these elements belong to the same period of the periodic table. So first of all, we have aluminum, then silicon, then phosphorus, and then sulfur. So this is basically the period trend. And the most important thing in period trend is that across the period, atomic size decreases. nucleus to valence electron attraction increases. So nuclear charge increases in short, shielding remains same. All right. So we are looking for the largest enthalpy change. And for largest enthalpy change, I think the largest enthalpy change would be the one which has more proton to electron attraction. Let's find out. We have aluminum 3+, so it has 13 protons and 10 electrons. Then we have silicon 4+, we have 14 protons and 10 electrons. Then we have phosphorus 3-, so 5+, sorry, 5+. It has 5 protons and 10 electrons. And then sulfur, which has 6+. Its atomic number is 16, so it has 16 protons and 10 electrons. So technically, all of them are isoelectronic because they have same number of electrons. So the greater the proton to electron attraction, the smaller the ionic radius. The smaller the ionic radius, the more difficult the removal of electron from the valence shell, which means silicon would be the right answer because it has more proton to electron attraction. All right. So I believe C is going to be the right answer. So the removal of electron from S6 to S7 would be very, very tough, very, very difficult because more energy is needed for the removal of electron because of strong proton to electron attraction. Also, the ionic radius of S6 plus would be the smallest among all these ions. All right. I hope it makes sense to you. Next question. Which sodium compound contains 74.2% by mass of sodium? Okay, so first of all, let me give you the MR of each compound. The MR of sodium carbonate is 106. The MR of sodium chloride is 58.5. You need to find out by using the periodic table. Okay, guys. So the MR of sodium hydroxide is 40. And the MR of sodium oxide is going to be, I believe, 23 times 2 plus 16 is going to be 62. Okay. So sodium carbonate has a formula Na2CO3. Sodium chloride has a formula NaCl. Sodium hydroxide has a formula NaOH. And sodium oxide has a formula Na2O. All right. So we need to find out the mass of sodium. All right. So let's apply the first one. Mass of sodium is 23. The AR of sodium is 23. We have 2 atoms in the formula, so into 2 divided by the MR, which is 106, into 100. So I believe it's going to be 40 something. 23 times 246 divided by 106, 43.3%. Okay. Now the next option B, percentage equals to mass of sodium is 23 and the number of atoms in the formula is 1, so into 1 divided by 40, divided by 58.5 into 100. So it's going to be 39.3%. Okay. Option C. Mass of sodium is 23 because the AR of sodium is 23 and the number of atoms in NaOH is 1 into 1 divided by the MR, which is 40 into 100. So it's going to be how much? It's going to be 57.5%. And last but not the least, option D. We have AR of sodium is 23. We have 2 atoms in the formula into 2 divided by the MR, which is 62 into 100. So it's going to be 74.1%. So 74.1%, that is 74.2. So I believe D is going to be the right answer. Okay. Let's start question number 4. What is the maximum volume of sulfur dioxide gas measured at room condition produced from the burning of 100 dm cube of diesel fuel containing 0.8346 gram of sulfur? So what we can do in the first step, that we need to take out the moles of sulfur. So we have 0.8346. We need to divide by 32.1 because the AR of sulfur is 32.1. So what I'm getting from by dividing these values, 346 divided by 32.1 is going to be 0.026 moles. Since moles of sulfur and moles of sulfur dioxide are same, so in order to calculate the volume of sulfur dioxide at RTP, I believe we need to multiply moles by volume, which is 24,000 cm3. So into 24,000 cm3 is going to be 624. So 624 cm3 is going to be the right answer. Question number 5. Which row shows the correct number of covalent bonds? I need the covalent bonds. Correct number of covalent bonds in a molecule of methyl propene. Methyl propene is also called 2-methyl propene. Let me give you the structure of methyl propene. This is the structure of methyl propene, which is also called 2-methyl propene. Let me open it so that we'll get the covalent bonds. CH3, C, CH3, double bond, CH2. So total number of sigma bonds in the molecule. Single bond is a sigma bond, by the way. So this one is sigma, sigma, sigma. All of them are sigma bonds. Bonds which are represented by red pen, all sigma bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 sigma bonds. That means A and B options are absolutely incorrect. Total number of pi bonds in the molecule. So if we have double bond, that double bond has 1 sigma and 1 pi, okay? Which means we have 1 pi bond in it, 1 pi bond. So I believe C is going to be the right answer, okay? All right, question number 6. Aluminum chloride exists as Al2Cl6. This Al2Cl6 is also called dimer. Dimer when 2 molecules combine together. When 3 molecules combine together is going to be trimer. When many molecules combine together is going to be polymer, okay? When heated to a high temperature, AlCl3 molecules are formed. By the way, this is the structure of AlCl3. We have 3 electrons in the valence shell of aluminum, and those 3 electrons are involved in the bonding, which means around aluminum we have 3 bond pair or single bond, and there is no lone pair. So total is going to be 3. If we draw 3 lines, in order to get hybridization, the first line is always represented by s orbital. The remaining 2 lines represents p orbital. So hybridization is going to be sp2. Whenever we have 3 single bond and a 0 lone pair with sp2 hybridization, geometry is going to be trigonal planar, and angle is going to be 120 degrees. So examiner is looking for the arrangement of the bonding pairs of electrons around the aluminum atom in the 2 forms of aluminum chloride. So I've got the first one, which is trigonal planar. That means option C and D are absolutely incorrect. All right. Okay, now the next is Al2Cl6. You guys know that Al2Cl6 has a structure like this. This is the dative one, by the way. And this is the dative one. Okay, an examiner is looking for the bonding pair of electrons around aluminum atoms only. So around this aluminum atom, we have 4 single bond and a 0 lone pair, which means total is going to be 4. Draw the 4 lines. The first line is always represented by s orbital. The remaining 3 lines represents p orbital. So hybridization is going to be sp3. If we have 4 single bond and a 0 lone pair with sp3 hybridization, angle is going to be 109.5 degree, and the geometry is going to be tetrahedral. So tetrahedral is here, tetrahedral is here. The right answer is going to be B. All right. And same geometry is going to be here. If you want me to find out the geometry of chlorine in this Al2Cl6, well, I have given you this instruction as well during the lecture. But let me calculate the geometry of chlorine in this molecule. Let's suppose chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6. This one is 7. Now around chlorine we have 2 bonds and 2 lone pairs, which means we have 2 bond pair and we have 2 lone pair around chlorine atoms. All right. So it's going to be 4. Hybridization is going to be sp3. Since we have 2 single bond and a 2 lone pair, the angle is going to be 104.5 degree, and geometry is going to be band shape. All right. Question number 7. The table shows the physical properties of 4 substances. Okay. Which substance has a joint covalent structure? A joint covalent structure. We have 4 different types. The first one is SiO2. The second one is silicon. Silicon also has a joint covalent structure. Then diamond. And then graphite. So answer could be any of these. All right. Let's talk about that. So they have high melting and boiling point for sure, because they have a giant structure. Which means option A and B is absolutely incorrect. Now competition exists between C and D. SiO2 cannot conduct electricity. Diamond cannot conduct electricity. So electrical conductivity of solid poor. Right. SiO2 and diamond cannot conduct. Electrical conductivity of liquid. Diamond cannot exist in liquid state. In fact, graphite cannot exist in liquid state. All right. Diamond, graphite, sand, and silicon cannot exist in aqueous solution. All right. So obviously C is also incorrect, and therefore D is going to be the right answer. But let me give you more detailed explanation. Since it has a high melting and boiling point, so both these values are correct. Electrical conductivity of solid could be poor because silicon dioxide cannot conduct electricity in solid state. Diamond also cannot conduct electricity in solid state. Both silicon dioxide and diamond and also graphite cannot exist in liquid state. So obviously that's the molecular giant covalent structure. Okay. Question number 8. At room temperature and pressure, H2O is a liquid and H2S is a gas. I've given you the explanation for this in the theory classes. You know H2O exhibit, oh my goodness, wait, hold on a second. H2O exhibit extensive hydrogen bonding, whereas H2S has only temporary induced dipole-dipole forces, also permanent dipole-dipole forces, and hydrogen bonding is stronger than both temporary and permanent dipole-dipole forces, which is why this is a significant hydrogen, which is why the state doesn't reflect the ionization energy criteria. So I mean to say that the state of any covalent molecule depends on the van der Waals forces and the types of forces they exist in it, right? And since ionization energy is the removal of electron, it has nothing to do with the states, which means option A is incorrect. Covalent bond also has no impact on the liquid state and the gaseous state, because the state has nothing to do with the covalent bonding. All right. For instance, if H2O is a liquid, obviously H2O gas is a steam, and also it exhibits covalent bonding. So bonding has nothing to do with this state. All right. See, there is a significant hydrogen bonding between water molecule significant hydrogen bonding means extensive hydrogen bonding, because one water has two hydrogen atoms. So it exhibits extensive hydrogen bonding, not between H2S molecule. Agreed. H2S doesn't have a hydrogen bonding. So this could be the right answer. This could be the right statement, but let me discuss the D. The instantaneous dipole-induced dipole forces between water molecule are stronger. Water molecule is a polar molecule. It exhibits permanent dipole-dipole forces, not instantaneous dipole-dipole forces. All right. So ultimately, C is going to be the right answer, and D is also incorrect. Okay. Question number 9. The enthalpy change for the reaction can be calculated from values of enthalpy change of formation. That's all. That's what we have done in the class. So if delta HF value is given in the question, we can find the value of delta HR without any issue. So that's the right statement. Similarly, we can find the enthalpy change of reaction by using the combustion data given in the table. It is also correct. And we can find the enthalpy change of reaction by using the bond energy values. All right. So all these data, if given in the question, we can find the delta HR, that is enthalpy change of reaction for any equation. All right. Since examiner has given us the combustion of ethane and it is converted into methane, carbon dioxide, and water. So technically, when ethane is combusted in the presence of oxygen, obviously carbon dioxide and water is formed, but this formation of methane is a question mark here, is a technical thing here, because during the combustion of ethane, we cannot find or we cannot produce methane gas. So I think only with the combustion data or only with the combustion value of ethane, we cannot find the delta HR value, because we need to find the combustion of methane as well. So what we can do is we can make the equation again. That is C2 H6 plus 3 O2, then 2 methane molecules, then 2 moles of carbon dioxide, and 2 moles of water. And that's the delta HR, which we need to find out. Okay. So first option is incorrect, because with the combustion value of ethane, we cannot find the delta HR. I need the data both for ethane and methane. Let's suppose if I'll use the combustion it will turn to next side and equals combustion of ethane. Methane, so value needs to be multiplied by 2. So standard enthalpy change of combustion of methane. All right. Apply the clockwise arrow. We can relate the this value is going to be positive, because both these values range plus delta H5C of methane times 2. This value is going to be negative because it is moving in the anti-clockwise direction. So this is my 2 delta HC or C2H6. All right. In order to find this, we can do is delta HR equals to 2 moles of delta H5C of methane. This is plus. If it move onto the, if it shifts towards the right hand side, obviously it's going to be minus. So it's going to be 2 moles of standard enthalpy change of combustion of methane. So that's the option is given in here. So I think B is going to be the right answer, all right, for this question. Question number 10. Which reaction has an enthalpy change equal to the standard enthalpy change of formation of propane? Propane. Standard enthalpy change of formation of propane. Propane has C3H8. It is a gas at room temperature and pressure. In order to make its equation, first we need to write carbon and then hydrogen. Now we need to balance it. We have 3 carbon atoms on the product side. Let's put 3 on the reactant side. We have 8 hydrogen atoms, so let's put 4 here. Under standard conditions, it is solid, it is gas. So which equation is given? 3C solid. 3C solid is here. 4H2 gas. 4H2 gas is here, which means this option is incorrect because it is gas. This option, oops, this option is incorrect because it is gas. It should be solid. And this option is also incorrect because it is hydrogen atom instead of hydrogen molecule. All right. This option is incorrect because it is liquid. It must be a gas. So right answer is going to be C. Question number 11. One of the reactions in the rechargeable lead acid battery is shown. Which statement about this reaction is correct? Lead is both oxidized and reduced. Guys, the oxidation state of lead here is 0 because it is neutral element. Over here, the oxidation state of lead is +4. Over here, the oxidation state of lead is +2. So technically, lead is oxidized and lead is also reduced. Oxidized when oxidation state changes from 0 to +2, and reduced when oxidation state changes from +4 to +4. So I believe A is the right answer, but let me check the other options. Lead is neither oxidized nor reduced. Well, it is oxidized and reduced, so B is incorrect. Lead is oxidized only. No, lead is reduced also. All right, lead is reduced only. No. So A is going to be the right answer. That's an easy question, by the way, right? So let's start question number 12, guys. KMnO4 is an oxidizing agent, obviously. It reacts with iron 2 ions, which is a reducing agent, obviously. It's shown in the following ionic equation. What are X and Y when equation is balanced? So we have discussed this in class. So I taught ion electron rules so that we can balance the ion electron equations. So let's apply that concept over there. Instead of oxidation state, I think that going to be the most easiest one. MnO4 negative is converting to Mn2 plus. We have 1 mole of manganese here, 1 mole of manganese here. We have 4 oxygen atoms. So let me write 4 water molecule as per rule on the product side. We have 8 hydrogen atoms on the product side. So to balance hydrogen atom, add 8 hydrogen ions on the reactant side. The overall charge on the product side is 2 plus, and the overall charge on the reactant side is +7. 8 plus and -1 is +7. So let's convert +7 into 2 +2 by using 5 electrons. Okay. Iron 2 ions is converting into iron 3 ions. An electron. We have 1 electron here. We have 5 electrons here, which means I need to balance number of electrons, and so that I will use 5 electrons, or I will multiply 5 electrons with the second equation. As the number of electrons are balanced on both the sides, they will cancel out with each other. So the final equation is going to be like this. MnO4 negative plus 8H positive plus 5 Fe2 plus arrow 5 Fe3 plus Mn2 plus 4 H2O. All right. So examiner is looking for X. X is 1. If no value is written, which means it is 1. Examiner is looking for Y. Y. So Y is 5. So right answer is going to be C. Question number 13. Nitrogen and hydrogen are mixed in a reaction vessel. The reaction reaches equilibrium, giving a mixture of nitrogen, hydrogen, and ammonia gases. The mixture of gases present at equilibrium at a total pressure of 300 atmosphere is shown. So these are the number of moles present at equilibrium. All right. What is the equilibrium constant Kp for the forward reaction? In order to find the value of Kp, first we need to find out the partial pressure of each gas, and before that we need to find out the total number of moles in the reaction vessel. So let's count the total moles first. So this is 180 plus 590 plus 160. I believe it's going to be 930 moles. Okay. Now let's find out the partial pressure of nitrogen. So moles of nitrogen is 180. Total moles is 930 into pressure. Total pressure is given 300. So the partial pressure of nitrogen is going to be 58.06. All right. Similarly, we need to find out the partial pressure of hydrogen. So moles of hydrogen is 590. Total moles is 930 into pressure, which is 300. So it's basically 190.32. Similarly, I need to find out the partial pressure of ammonia. So moles of ammonia is 160 divided by total moles is 930 into pressure, which is 300. So it's going to be 51.61. Okay. So these are the partial pressures. Now by using these values, I can find the value of Kp, but before that I need to write the Kp expression for the equation. That's partial pressure of ammonia. Since we have 2 moles on the product side, so this has to be in the power over partial pressure of nitrogen times partial pressure of hydrogen. Since hydrogen has 3 moles, it has to be in the power, which is Q. Partial pressure of ammonia is 51.61. It's a square over partial pressure of nitrogen is 58.06 into hydrogen is 190.32 power Q. So Kp is going to be 6.65 into 10 to the power minus 6. All right. So let's suppose it is atmosphere square. It is atmosphere 4. Atmosphere 4 is basically 1 over atmosphere square. So final unit is basically atmosphere inverse 2. So 6.65 into 10 to the power minus 6. A is going to be the right answer. Okay. Okay. Question number 14. A mixture of hydrogen gas and iodine gas is placed in a reaction vessel of volume V at temperature T. The reaction of hydrogen and iodine reacting together, converting into Hi, is allowed to come to equilibrium. All substances remains in the gaseous state. Argon gas is then pumped into the reaction vessel. The temperature in the reaction vessel is maintained at T. How are the rate of forward reaction and the partial pressure of Hi at equilibrium affected? Okay. So the reaction is reversible and we are maintaining the temperature. So definitely kinetic energy would remain same. Since we have 2 moles on this side and we have 2 moles on product side, so as the number of moles on both the side is same, so there will be no effect of pressure. So the partial pressure of Hi at equilibrium would be unaffected. So that's a very straightforward information. But yes, let's talk about why. What happens if we add argon gas? So the point is, argon is an inert gas. Cannot react with hydrogen and iodine. So it cannot change the concentration hence rate of forward reaction will remain unchanged. So I believe it will remain unaffected, and therefore D is going to be the right answer. Two experiments are carried out to study the reaction between zinc and sulfuric acid. Small lumps of zinc are added to excess dilute sulfuric acid. If it is a small lump, obviously the reaction is going to be faster because of large surface area. Large surface area, higher rate. Higher rate of reaction. Okay. The reaction is carried out at a lower temperature with one other change. If lower temperature means slow reaction rate would be slow. Why are we using excess sulfuric acid? To make sure the zinc has been reacted. Make sure all the zinc has been used. Okay. Both experimental procedure produces the same total volume of gas and are completed at the same time. Same time. That's a very, very powerful statement. If reaction completes in the same time, then they will have the same rate of reaction. Okay. And if temperature is lower, reaction is slower. Why reaction is slower? Because of lower kinetic energy and collision frequency. Lower kinetic energy, lower collision frequency. Okay. So what is the second change made in experiment 2? If I'm getting the same total volume, which means the amount in both the experiment would be same. Amount would be same in both experiment. That means rate of reaction increases. Although the temperature is lower, it lowers the rate of reaction or slower the rate of reaction. But when we add catalyst, it increases the rate of reaction, which is why both the reaction finishes at the same time. So that's the only option left for me, I believe, after such analysis. So I believe A is going to be the right answer. Okay. What if we use greater volume of sulfuric acid? Volume is already in excess. All right. So if we use greater volume, obviously pressure is going to be lower. If pressure is going to be lower, collision frequency is going to be lower. Rate of reaction is going to be lower. And if reaction rate is going to be lower, obviously, then reaction is not going to finish at the same time, which means C option is incorrect. Okay. Greater mass of zinc. Well, we have already excess dilute sulfuric acid, so we cannot take zinc in excess amount. Otherwise, we cannot find the limiting reactant in that way. Larger lumps of zinc, larger lumps is also incorrect, because whenever we use larger lump, obviously lower surface area, slower the rate of reaction. Okay. Question number 16. The relative magnitude of the property X of 5 elements is shown P, Q, R, S, and T, or in the period 3 and have consecutive atomic number. Okay. I don't know what period 3 elements are these, because they haven't given me any atomic number or all that. But let's suppose it is sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. 5 elements in consecutive. 1, 2, 3, 4, 5. So this could be from aluminum to chlorine. Or this could be 1, 2, 3, 4, 5. This could be sodium to phosphorus. Okay. So this could be sodium to phosphorus, I believe. Okay. So R has the highest physical property. So chlorine is the most electronegative element in period 3. So if it is electron negativity, obviously silicon would not be the correct option, because chlorine is the most electronegative element. Obviously B is going to be the incorrect option. If R has the highest melting point, so I know that silicon is the highest melting point among all these period 3 elements. And over here we have written aluminum, which means option C is also incorrect. Okay. I believe A is going to be the right answer, because aluminum has the highest electrical conductivity. This is sodium, this is magnesium, aluminum, silicon, and then phosphorus. So aluminum has the highest electrical conductivity because it contains maximum valence electron, because it has maximum valence electron. Okay. The second across the period ionization energy increases, which means chlorine has the first ionization energy. So if it has the highest first ionization energy, this must be chlorine. But this is, and this obviously the second ionization energy of chlorine is also highest, which means option B is also incorrect. Okay. Question number 17. Element X in period 3, element X reacts with oxygen to produce a solid Y. Okay. So we have period 3 elements, sodium. So option, let's talk about magnesium also, aluminum, silicon, phosphorus, sulfur, and then chlorine. Okay. When elements react with oxygen to produce solid Y, so it produces sodium oxide, it produces magnesium oxide, aluminum oxide, silicon dioxide, P4O10, SO3, and Cl2O7. Okay. When solid Y is added to water, a solution of pH less than 7 is produced. Obviously, more than 7 pH because of the formation of sodium hydroxide, more than greater than pH 7, neutral because it is insoluble in water, so pH will remain 7, insoluble, neutral, pH will remain 7. So this could be, this could be, this could be, give you an acidic solution when placed in water. Okay. Also, you can say that aluminum and silicon are insoluble in water. Both of them gives both of their oxides gives an alkaline solution of pH greater than 7. Examiner is looking for the pH less than 7. So let me give you an explanation here. What could be the right option? Do we have sulfur? So P4O10 gives you H3PO4 when placed in water. Let me give you the equations here. H2O plus P4O10, you will get H3PO4. All right. When SO3 is treated with water, it will turn to H2SO4. And when Cl2O7 is placed in water, obviously 2HClO7 is formed. Since chlorine is not here in the option, so we can ignore it. Silicon is also incorrect. For sodium is also incorrect because sodium produces alkaline solution, silicon is insoluble. The competition exists between sulfur and phosphorus. So sulfur produces H2SO4, H3O4 produces this, and sulfuric acid is a stronger acid than H3PO4. And solid Y, and solid Y. Oh, 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 okay, 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 okay. That's a very, very technical aspect. When element X reacts with oxygen, produces solid Y. So sulfur trioxide is basically a gas at room temperature and pressure. So I will cancel this equation also. So right answer is going to be C. All right, because P4O10 is a solid at RTP. It is solid at RTP. That's very, very technical. Solid. Sorry. Question number 18. This question refers to isolated gaseous species. The species fluoride, neon, and sodium are isoelectronic. Isoelectronic are those which contain same number of electrons. We have discussed this in class, which means all of them have same number of electrons. In which order do their radii increases? I've given you certain information regarding the initial classes when we have started the AS level course. First of all, I've told you the size of cation smaller than neutral atom because of a strong proton to electron attraction. Similarly, the size of anion is greater than the neutral atom because of the electronic repulsion, which means fluoride has the largest radii and the sodium ion is the smallest radii, and obviously neon has to be between them. All right, so I think C is going to be the right answer. Okay, question number 19. Separate samples of magnesium and calcium are added to excess dilute sulfuric acid. When we add magnesium in H2SO4, it is converting into magnesium sulfate and hydrogen gas. So bubbles of gas is given out, all right? And when we add calcium in sulfuric acid, reaction takes place, and as a result, calcium sulfate and hydrogen gas is produced. I've told you in the class that magnesium sulfate is soluble in water. whereas calcium sulfate is insoluble or partially soluble in water. Basically insoluble in water, okay? Because down the group, the solubility of group 2 sulfates decreases. We have discussed this important topic in the class, all right? And you guys need to repeat that, revise that. The magnesium, vigorous reaction, bubbles of gas produce, magnesium completely dissolved, that's right. Okay. Now the next is vigorously react initially, bubbles of gas produced, that's right. Reaction soon stops and leaves most of the calcium unreacted. That's right, because when calcium sulfate is formed, this calcium sulfate will deposit on the calcium metal, and that calcium sulfate will block the reaction, which is also called blocking reaction. So this is basically the blocking reaction. So calcium is better oxidizing agent than magnesium. Oh my goodness, calcium is metal, and metals are reducing agent, not oxidizing agent. So option A is incorrect. Calcium is better reducing agent than magnesium. Well, down the group, reducing power of group 2 elements increases. So from that perspective, the statement is going to be right. But since both of them are back to back, so there is no as such difference in the reducing power of both the elements. So I must say that down the group, reducing power increases, but this reducing power has nothing to do, nothing explain why the reaction stops after some time and leave most of the calcium unreacted. So this reducing power doesn't explain this whole scenario, all right? So I believe B is also incorrect. Magnesium is more reactive metal. No, down the group reactivity increases, so calcium is more reactive. That's wrong, all right? So D is going to be the right answer because magnesium sulfate is soluble. Reaction can react, magnesium can react easily, whereas calcium sulfate deposit on the calcium metal, that blocks the reaction, and therefore after a short lapse of time, most of the calcium will remain unreacted. All right, so D would be the right answer. Dolomite is a double carbonate, calcium magnesium carbonate, and can be used instead of calcium carbonate for treating acidic soil. The three statements all refer to the agricultural use of these carbonates. Dolomite and calcium carbonate are both less soluble than the calcium hydroxide. That's a right statement because calcium and magnesium carbonate, carbonates of calcium and magnesium, are insoluble in water, whereas calcium hydroxide is an alkali, which is water soluble. Okay. Now, in the next statement, 1 mole of dolomite, and dolomite has 2 carbonate ions, right? Has the same neutralizing effect. So if dolomite has 2 carbonate ions, which means it will react with 4 hydrogen ions, converting into 2 moles of water and 2 carbon dioxide. All right. So that's for the dolomite. As 1 mole of calcium carbonate. So 1 mole of calcium carbonate has only 1 carbonate ion. So when you treat it with hydrogen ions, it will turn to water and carbon dioxide. So basically, the statement is absolutely incorrect because it has not the same, not same, right? Because calcium carbonate requires 2 moles of hydrogen ions, whereas dolomite requires 4 moles of hydrogen ions, so they will not have the same neutralizing effect. Now, dolomite and calcium carbonate both increase the pH of acidic soil. That's correct, because calcium carbonate and magnesium carbonate are have alkaline solutions, so they will have they can basically increase the pH of the acidic soil. So I believe 1 and 3 option is correct, and therefore B is going to be the right answer. Like question 21, about two salts, sodium hydride and sodium chloride. The two solid salts are separately added to warm concentrated H2SO4 and the result noted. Okay, first we have discussed this in class. And so when sodium chloride is treated with H2SO4 concentrate, you get hydrogen sulfate salt and misty fuse of HCl. Okay, which means concentrated H2SO4 cannot oxidize chloride into chlorine, it will remain HCl. The second equation is basically sodium iodide. When reacting with H2SO4, it is converting into sodium hydrogen sulfate initially with misty fumes of HI. Now, this misty fumes of HI, when treated with concentrated H2SO4, then H2S gas is formed, which has a rotten smell, and water. Okay, and this is going to be a iodine. All right, that was the equation we have discussed in the class. Now, in the next part of the question, aqueous solution of the two salts are separately added silver nitrate. So when we add silver nitrate, Cl, obviously placed in AgI. Sorry, AgNO3, it will turn to AgI, which has a yellow precipitates. Okay. And you know, white precipitates of AgCl are soluble in aqueous ammonia, and that will give you colorless solution, whereas it will remain insoluble with aqueous ammonia. Okay. Okay, which row is correct? So we have sodium chloride. When it is reacted with concentrated H2SO4, chlorine cannot be produced. So option A is incorrect. Similarly, when sodium chloride is treated with concentrated H2SO4, it cannot produce H2S gas, which means B is also incorrect. When sodium iodide is treated with concentrated H2SO4, it releases H2S gas. That's written. Okay, that's fine. And when silver nitrate is treated with NaI in aqueous ammonia, yellow precipitates will remain. That's true. So that C is the right answer. Okay. Sodium iodide, when treated with concentrated H2SO4, it produces iodine. That's right. That's right. But AgNO3 and iodide yellow precipitate may decomposed on heating. You will get calcium oxide, nitrogen dioxide, and oxygen gas. Okay. When strontium nitrate is decomposed on heating, you will get strontium oxide, nitrogen dioxide, and oxygen gas. All right. Calcium nitrate has more charge density has more charge ionization decomposes easily. And down the group, ionic radius increases. So strontium ion has less charge density and polarization. So decomposition is not easier. So not decomposes easily. It requires a lot of temperature for thermal decomposition. Which row describe the color change and identify the nitrate and causes the quickest color change? Universal change of color change of universal indicator. Oh, oh. Let me read the whole question again. As the reaction proceeds, the water containing universal indicator changes color. Okay. So this oxygen is neutral. It has no effect on the universal indicator. But this is acidic gas. When it is placed in water, it will turn to an acidic solution. Obviously, this solution is going to be acidic because NO2 is soluble in water. Okay. Let me write one more statement here. NO2 gas. NO2 is acidic gas. So forms an acidic solution in water. All right. So in acidic solution, the universal indicator shows red color, and nitrate that causes the quickest change color. Quickest change takes place when decomposition becomes easier. So calcium nitrate would be the right answer because the decomposition takes place quickly, easier. So C is going to 23 equations for three reactions for these. Equation 1 describe the formation of a compound used to kill bacteria in drinking water. Kill bacteria in drinking water? Not. That compound is basically HClO. And equation 1, there is no HClO. Okay. So option is incorrect. Equation 1 does not represents a redox reaction. It does represents a redox reaction because the oxidation state of chlorine here is +5. Over here, the chlorine is -1. So oxidation state changes from +1 to +5 to +1, that is reduction. So +1, +5 to -1, that is reduction. And over here, the oxidation state of oxygen is -2. Over here, the oxidation state of oxygen is 0. So -2 to 0 is basically oxidation. So it's a redox reaction. So E is incorrect. Okay. Let's talk about C. Equation to describe the formation of potassium chlorate 4. Potassium chlorate 4. Potassium chlorate 4. Let me find out the oxidation state of AClO4. Chlorine X, potassium is +1. Oxygen is -2 into 4 equals to 0. Then -7 equals to 0. Then X equals to +7. So it is potassium chlorate 7, not 4. So right answer is going to be D. Nitrogen monoxide is a primary pollutant produced by petrol engine and is found in the car exhaust, which reaction occur in the catalytic converter and decrease the emission of the nitrogen monoxide. We have discussed this equation in the class. I've told you that we have nitrogen monoxide. It is reacting with carbon monoxide, converting into carbon dioxide and nitrogen gas. So let me check which equation shows this option. Not this one, because still pollutant is released. Not this one also, because pollutant is released. So C is going to be the right answer. Again, part D, not because pollutant NO2 is also released. But that's not possible. Pollutant shouldn't be released when catalytic converter is used, all right? So C is going to be the right answer. Question number 25. The diagram shows the structure of the naturally occurring molecule cholesterol. Student X stated that 17 carbon atoms in the four rings, 1, 2, 3, 4 rings, all lie in the same plane. Since the structure is tetrahedral, so they cannot lie on the same plane, which means the student X is incorrect. Then student Y stated that this molecule displays cis-trans isomerism. By the way, I've told you in the class, when we have a cyclic ring with double bond, then it exhibits only cis isomer, not trans, because of bond pair repulsion. So student Y is also incorrect. So which is student correct? Neither students nor students Y. B is going to be the right answer. 26. The drug cortisone has the formula shown. In addition to those chiral center marked by an asterisk, how many other chiral centers are present in the cortisone molecule? This is 2 hydrogen atom. This is 2 hydrogen atom. This is double bonded carbon. This is 2 hydrogen atom. So this shouldn't be the chiral, not chiral because of double bond. Because of 2 hydrogen, no chiral. Because of 2 hydrogen, no chiral. Because of 2 hydrogen, no chiral. Double bonded carbon, double bonded carbon, double bonded carbon. Two similar hydrogens, double bonded carbon, three similar hydrogens, two similar hydrogens. So I believe how many chiral carbon atoms left? This one, and this one. Only 3 chiral carbon atoms left, right? Apart from steric. So D is going to be the right answer. So let's start question number 27. Yes. Butene reacts with cold dilute acidified KMnO4 to give product X. So butene is basically CH3, CH double bond, CH, and then CH3. You can make this skeletal structure as well. And when you treat it with acidified KMnO4 and cold dilute, obviously you will get diol. And that diol is basically product X. This is CHOH. This is CHOH. And this is CH3. That's your product X. Okay. And that's your diol. On the other hand, if butene reacts with hot concentrated acidified KMnO4, it will give product Y. So when we have CH3, CH double bond, CH, CH3, and it is reacting with hot concentrated KMnO4, obviously this double bonded CH will turn to CWH, so you will get ethanoic acid only. In fact, 2 moles of ethanoic acid. And that's your product Y. And that's your carboxylic acid, okay? Option 1. Which statement about product X and product Y is correct? Correct option, okay? Which statement is correct? So right answer, let's suppose both product X and product Y will react with 2,4-DNPH, that is 2,4-dinitrophenylhydrazine. They cannot react with 2,4-dinitrophenylhydrazine because 2,4-dinitrophenylhydrazine cannot react with alcohol, cannot react with carboxylic acid, can only react with aldehyde and ketone. So option A is incorrect. Neither product X nor product Y will react with 2,4-D and pH. That's the right answer, I must say, because alcohol and carboxylic acid cannot react with 2,4-dinitrophenylhydrazine. Let's talk about other options. Product X will react with 2,4-dinitrophenylhydrazine, but product Y cannot. Again, that's an incorrect option because they cannot react. Product X and product Y cannot react with 2,4-dinitrophenylhydrazine, and therefore C and D options are also incorrect. So B is going to be the right answer for question number 27. Let's talk about 28. A sequence of reaction takes place. The major product is compound Z. So examiner is looking for the major product of compound Z. So when propanoic acid is treated with lithium aluminum hydride, it will turn to propane 1-ol. That is your primary alcohol, okay? And when concentrated sulfuric acid is used, then dehydration takes place. So remember, first one is reduction. The second one is dehydration or elimination. And when dehydration or elimination reaction takes place, propene is formed. And when propene reacts with steam over phosphoric acid, uh, obviously propane 2-ol is formed. Along with propane 1-ol. And propane 1-ol is formed through 1 degree carbocation. And propane 2-ol is formed via 2 degree carbocation. And 2 degree carbocation is more stable than 1 degree carbocation, which means this is going to be the major product. And this is going to be the minor product. Okay, that's what we have discussed in the class as well, in the lecture. So what compound is Z? The compound Z is propane 2-ol, so D is going to be the right answer because his examiner is looking for the major product. Okay. Question number 29. Which statement is correct? Bromoethane, which is your alkyl halide, reacts with NaOH. You will get ethanol to form ethene. No, it's wrong. It's basically ethanol. That statement is incorrect. Then 1 chlorobutane reacts with more rapidly than 1 bromobutane with NaOH at the same temperature when carbon chlorine bond is shorter and carbon bromine bond is weaker. So this bond is weaker, its bond length is higher, so it can take place more rapidly. So reacts less rapidly because of its less reactivity. Remember, the reactivity of alkyl halide is RCl is less reactive than RBr. RBr is more reactive, is less reactive than Ri. That was the reactivity order. Okay. Let's talk about C. Hydrolysis of this compound. Basically, this is tertiary alkyl halide. This is 3-degree alkyl halide. This is 3-degree alkyl halide because bromine attached to the carbon atom has no hydrogen, or you can say bromine attached to carbon is surrounded by 3 neighbor carbon atoms. So it is tertiary alkyl halide, and tertiary alkyl halide always takes place or always occur via SN1 mechanism, not SN2. So C is also incorrect, and therefore D is going to be the right answer. Let's talk about D. This carbocation is less stable than this one. That's true. This is 1 degree carbocation, and this is 3-degree carbocation, and 3-degree carbocation is more stable than 1 degree. So D is going to be the right answer. This is less stable, and this is more stable. Okay. Question number 30. In the hydrolysis of bromoethane by aqueous NaOH. So we have bromoethane, ethane. Okay, bromoethane. It is reacting with NaOH, converting into ethanol. And NBr. what is the nature of the attacking group and of the leaving group. Now, in this hydroxide ions are the attacking nucleophile, or you can say attacking group. So OH is basically your nucleophile, okay? Attacking nucleophile or attacking group. Leaving group. So bromide ions are the leaving group or leaving nucleophile because it is a nucleophilic substitution reaction. So leaving nucleophile. So the right answer is going to be D. Question 31. X is an organic compound containing the element carbon, hydrogen, and oxygen only. The table shows the observation made from the 3 chemical tests carried out on X. Sodium metal effervescence is seen. Then it means it can be alcohol or carboxylic acid. Sodium carbonate effervescence, that means CWH present. Hot acidified potassium dichromate 6 remains orange. Either it is carboxylic acid or 3-degree alcohol. Okay, because tertiary alcohol cannot oxidize. What is the possible structure of X? So we have carboxylic acid. That's right. That can give sodium metal and sodium carbonate. So this gives sodium metal and sodium carbonate test positive, right? But this is secondary alcohol, can oxidize. So that's wrong. Option A is wrong. This is an aldehyde. No sodium carbonate, no sodium metal test is possible. Sodium metal test is not possible. Sodium carbonate test is not possible in this. And this could also oxidize. An examiner is saying there is no oxidation because there is no change in the color of potassium dichromate 6. Obviously, B is also incorrect. But let's talk about C. This is tertiary alcohol. This is 3-degree alcohol. So cannot oxidize, that's right. But this is aldehyde. An aldehyde has no test of, cannot show sodium test, cannot give you sodium carbonate test. So obviously C is also incorrect, and therefore D is going to be the right answer. Why D is correct? Because this is tertiary alcohol, 3-degree alcohol. So cannot oxidize. And also it is carboxylic acid. So this acid gives sodium metal test. This acid can give you sodium carbonate test as well, right? So both these reagents gives positive test. So D is going to be the right answer. Okay, question number 32. How many moles of oxygen gas are needed for the complete combustion of 1 mole of this compound? So how many carbon atom in this? 3 times 1, 3 and 1. C4H10O is treated with oxygen, converting into carbon dioxide and water. How many oxygens here? 4 times 2, 8, 8 plus 5, 13. So we have 6, 6 times 2, 12, 12 plus 1, 13. So 6 moles of oxygen. A is going to be the right answer, okay? That's an easy question, guys. First of all, what you can do is determine the molecular formula of this compound. This is tertiary alcohol. This is 2-methyl propane 2-ol. All right, we have in this compound we have 4 carbon atoms. We have 10 hydrogen atoms. We have 1 oxygen. Okay, So that's an easy thing. Anyway, next, in which pair will each compound give a different visible test with alkaline aquacidine? With alkaline aquacidine has two different options. The first one, in fact, we should have three different options. The first one is it must be ethanol because ethanol gives positive test of hydroform. Second thing, if it is secondary alcohol, then CH3CHOH group should be present in the molecule. If it is aldehyde or ketone, obviously CH3CO group should be present. All right, let me check which scenario exists in the option. Now, different visible result. Examiner is looking for different visible result. So this will give you positive test. This will give you positive test. So same visible result in this, not different. That means option A is incorrect. This will give you positive test because it has CH3CO group. This one also has CH3CO group, which means same visible result again. Cannot get different result. This is carboxylic acid. Carboxylic acid cannot give positive test of hydroform. This one cannot give positive test of hydroform because it doesn't have CH3CO group. So again, they cannot react. You will get the same visible result. The right answer is going to be D. Let me check D. This will give positive test. And cannot give positive test because it doesn't have CH3CO group. How can I decide so quickly? Because I have an idea about the structure. If you have an idea about the structure, you can decide without any issue. So that's the structure. That's the formula. Now, this formula doesn't have this group, right? Which means this cannot give you test. So D must be the right answer because you will get the different visible result in that particular option. Okay. Let's move on to the question number 34. Which reagent give a positive result with propanol? Propanol is ketone. Ketone gives 2,4-DNPH test positive. Cannot oxidize. Oh, hold on a second. Hold on a second. My bad. Just one more thing. Also, give positive test of iodoform because propanol has a structure like this. So this compound has CH3CO group, which means it can give you positive test of iodoform. Ketone cannot tolerance and Felling reagents, so cannot test with Felling and tolerance reagents. So C and D options are incorrect. Aqueous bromine can only react with alkene, so A is going to be the right answer because it can react with positive test. Can react with alkaline aquacidine because it will give you positive test of iodoform. Let me give you the equation here. I have given you the equation in the class. I've given the mechanism. So when you reacted alkaline aquacidine, this CH3 will turn to CHI3. Plus CH3CO will remain as it is. And this CO will get OH of water will turn to CWH. And that ultimately will turn to salt because of alkaline medium. Okay, that's your salt of carboxylic acid. Anyhow, let's move on to the next part of the next question. In fact, question number 35. Oh, esters. Esters can be hydrolyzed with an aqueous alkali or an aqueous acid to form two products. Let's suppose this is your ester, all right, and if we hydrolyzed it with water, and that's a reversible reaction, either we can use H plus sign or OH negative ion, totally up to you. Simultaneously, we cannot use these two reagents, all right? Either we can use H plus signs or either we will go for the alkaline medium. Anyhow, if it is acidic medium, let me give you one by one. If it is H plus sign, it will give you carboxylic acid and alcohol. All right. But when it is reacting with water in the presence of alkaline medium, obviously you will get salt of acid and alcohol. Okay. So which row is correct? And the table compares the two methods. Aqueous acid forms an equilibrium mixture. Equilibrium, because of this reversible sign, forms an equilibrium mixture of carboxylic acid and alcohol, organic acid and alcohol. That's right. Complete conversion to salt and alcohol. In organic acid, there is no salt, so this option is incorrect. Forms an equilibrium mixture with organic acid and alcohol. That's also right. Complete conversion of organic acid and alcohol. It's not a complete conversion because of this reversible sign. Okay. So this seems to be correct also. Yeah, this seems to be correct. Because what I'm thinking is when we use acidic medium, then the product will remain same. The product has no effect on this condition, all right? Because that acid is acting as a catalyst. So that might be the correct option. That might be the right statement as well, okay? Let me check other options. Aqueous alkali, complete conversion to salt and carboxylic acid. Salt and organic acid. Not organic acid, it must be an alcohol. So option A is incorrect. Forms an equilibrium mixture with a salt and an organic acid. That's right, because there is an equilibrium mixture of salt and alcohol. Oh, again, that's a wrong statement because organic acid is there. It must be an alcohol. If it is salt and alcohol, okay, so that's also incorrect. Complete conversion to salt and an alcohol. That's right. Complete conversion of salt and an alcohol. How can what I'm missing here? Complete conversion to salt and an alcohol. Complete conversion to an organic acid and an alcohol. Salt and alcohol. I think there is an equilibrium established here, all right, when this hydrolysis takes place. So I believe this is going to be incorrect. I believe C is going to be the right answer, okay? So if this statement is wrong, because there is an equilibrium reaction going on, and as a result of that, you will get carboxylic acid and alcohol, that means option D is also incorrect. Because there is no complete conversion, there is an equilibrium mixture, okay? So I think C is going to be the right answer from my perspective. Question number 36. The structural isomerism only should be considered when answering this question. The structural isomerism includes chain isomerism, position isomerism, and functional isomerism, all right? How many compounds with molecular formula C5H11Br are primary halogen Examiner is looking for the primary alkyl halide, and primary alkyl halide are those which contain RCH2X group. So examiner is looking for this group, all right? And we have the formula. So let me write the structure. That's easy. This is CH3, CH2, 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 CH2Br. This is first structure. Then CH3. Let me make the chain isomer first. CH3, CH, 1, 2, 3, 4. This one is 5. The third one is, what if we shift this methyl branch onto that carbon atom? CH3, CH2, CH, CH3, and CH2Br. What if I'll shift this CH2 onto that carbon and hydrogen to this carbon atom? So again, I'll get tertiary, or I'll get again primary alkyl halide. Is there any other possible way? This is primary alkyl halide, guys. This is primary. This is primary. This is primary. This is primary alkyl halide. Since alkyl halide, I cannot, primary alkyl halide cannot undergo functional isomerism, which is why I didn't go for that. Number one. Number two, I cannot go for the positional isomerism, because if I'll shift bromine from this carbon to that carbon, obviously it's not going to be the primary halogenoalkane, then it's going to be the secondary alkyl halide or secondary halogenoalkane. So I have to stick to primary, which is why I cannot shift the bromine atom. All right. So there's only possibilities left for me, and therefore A is going to be the right answer. I think so. Yeah. A structural isomerism only. 4. Okay. 1, 2, 3, 4. Yeah. Question 37. Compound Z is formed by the reaction scheme shown. This is your alkyl halide reacting with KCN. Obviously, the compound X should be CH3, CH2, CN, that is propane nitrile. When propane nitrile is treated with dilute HCN, acid hydrolysis takes place under reflux condition, and obviously the compound Z would be CH3, CH2, and CN will turn to CWH because of acid hydrolysis. Okay, so what is the formula of compound Z? That's propanoic acid, and therefore D is going to be the right answer. With one thing, this is nucleophilic substitution reaction. In short, this is SN2 reaction because it is primary alkyl halide. This is acid hydrolysis. Whenever nitrile functional group we have in the molecule and you undergo acid hydrolysis, it will turn to CWH. And the rest of the molecule will remain same. That's an easy question, guys. Was expecting very difficult questions in Feb March paper. Oh, question 38. Hydroxyethanol. That functional group, that means it has primary alkyl halide and an aldehydic functional group. So this compound has two different functional groups. The first one is primary alcohol and the other one is aldehyde. Is heated under reflux with an excess of acidified potassium bichromate 6 until no further oxidation takes place. What is the skeletal formula of the organic product form? That's an easy question. We have discussed, if you remember, we have discussed synthetic route. In that, I've told you that whenever potassium dichromate 6 in acidified meat condition is used under reflux condition with excess amount, obviously this aldehyde is going to be converted into carboxylic acid, and this primary alcohol will turn to carboxylic acid again. So that is the final product of this reaction. And if you want to make skeletal structure, you can draw it like this. And this structure is basically this. All right. So B is going to be the right answer. That's an easy question, guys. Question 39. The formula shows the repeating unit of an addition polymer. What is the correct name of the monomer from which this polymer is made? I've told you in the class that it's possible in the question in the paper that examiner has given us a polymer, and from that polymer he wanted us to determine the structure of the monomer. So let me draw this. Let me draw this structure. Similarly, this carbon has one H and one CH2 and then one CH3. All right, which means 1, 2, 3, 4, 5 carbon atom we have. That means these two carbon atom must have the double bond. So this is CH3, CH. So the monomer. So in the monomer, we have double bond between the carbon atom, and the double bond must exist between these two carbon atoms. So this is going to be the monomer from this polymer. That's the criteria, that's the strategy. So this is first carbon, second carbon, third carbon, fourth carbon, fifth carbon. This is pen-2-ene. Right answer is C. Let me write this. Let me write this in a structured form. This is CH3. Then this is CH, double bond CH, then CH2, and then CH3. Let me give you the number of carbon atom both from the right hand side and the left hand side. Fourth and fifth. 1, 2, 3, fourth, and fifth. So I'll go for this side because this side has lowest position of the functional group, which means it is pent because we have 5 carbon. Since second carbon has functional group, so it's 2-ene. So that's the answer for question 39. Let's move on to the last question. The infrared spectrum of a compound is shown. Okay. So this is 1100, this is 1200. Now this peak appears at 1200 centimeter inverse, indicate that it is C single bond O. I've told you that it's a fingerprint region from 500 to 1500, but in that fingerprint region, you have a peak of C single bond oxygen at 1200 centimeter inverse. Okay, that is written here. So this peak shows that either we have hydroxy functional group or either we have ester functional group. So let's read infrared spectrum again. This is 1500, 1600, 1700. So this peak at 1700 approximately indicates that we have carbonyl group. So if we have carbonyl group, if we have CO group, when these two groups combine together, you will get an ester. So that's the confirmation that we have ester in this compound. Okay. How about this one? This peak is basically represents CH because it appears at 3000 centimeter inverse. It's not a broad peak. It's not a very broad peak, which means it's not carboxylic acid. So it's basically an ester because we have C single bond O and we have C double bond O. So we have an ester. So right answer is going to be C. Option A is absolutely incorrect because alcohol is a functional group, and that functional group peak appears at 3350 centimeter inverse, and this peak is not given in the spectrum. So alcohol should be out from these options. Carboxylic acid peak appears at 3000 centimeter inverse, but this peak needs to be very broad, and the shape has to be like that, and this shape is not given in this spectrum, which means it's not carboxylic acid. By the way, nitrile is CN, and then CN has a peak of 2250 centimeter inverse, and there is no peak at 2250 centimeter inverse. There is no peak absent. All right. and therefore Aster is going to be the right answer. I hope it makes sense to you. Thank you very much.